Okay, this is still section 2.4. What we're going to look at next is piecewise functions. For example, suppose that f of x is given here. Now a piecewise function is one that contains several parts. Okay, so usually we have like a some sort of a parentheses or a bracket of some kind enclosing all the parts, and there's conditions on each statement. I want to do a couple things with this. The first thing I'd like us to do is graph f of x. So the first thing is to graph each piece. And I'm going to ignore the if statements. I'll come back to those at the end. Okay. I need to graph two lines, y equals negative 1/2 x plus 2, and y equals x minus 1. Y equals negative 1/2 x plus 2 means that y is equal to means that the y-intercept is at 2. Okay, and I can use the slope negative 1/2, and that's a negative 1/2. So I know I'm going up 1 and to the left 2. Now I don't want the entire line drawn. Okay, I only want the part of the line for when x is less than or equal to 0 to be included. So when x is 0, anything less than 0 needs to be included. Anything bigger than 0 needs to be erased. The next piece, y equals x minus 1, has a slope of 1 and a y-intercept at negative 1. So 0 and negative 1 is where I'd start, and I'd use the slope of 1. Okay, or I can go down 1 to the left 1 each time. Okay, and now I don't want the entire line. I only want the part for when x is greater than 0. So anywhere that is greater than 0, I need to keep. Anywhere that is 0 or less, I would need to erase. X is strictly greater than 0, so 0 negative 1 should not be on the graph. Okay, notice how what I've got now passes the vertical line test. And that's critical for a piecewise function. Function f of x means that I've got to pass the vertical line test. Okay. As far as the domain of f, it's all real numbers. Okay. If I scan the x-axis, I'm anywhere on the graph. The range of f is the set of all y such that y is greater than negative 1. So check it out here. If I'm at negative 1 or bigger, and I look to the left and to the right, I'm going to be on one of the two pieces. If I'm at negative 1 or less, I'm not on the graph at all. So now x is strictly greater than negative 1 because of this open circle that I've got there. Okay? The intercepts, there's two of them, 0, 1, or 1, 0, and 0, 2. Okay? And the intercepts, of course, are where the graph would cross or touch the axes. F of 2 is 2 minus 1 is 1. Okay, 2, 1. Yeah, that's that point right there. F of negative 2, I'd use piece 2 or piece 1, since negative 2 is less than 0. Negative 1/2 times negative 2 is 1, plus 2 is 3. So negative 2, 3. Yeah, that's that point right there. Okay, is the function continuous? No. Continuous means that I could draw the whole thing without lifting the pencil from the paper, and at 0, I'm going to have to lift the pencil to get to the second piece there. Okay. Another piece is, piecewise function, is f of x equals x plus 3 if x is in between -2 and 1, including -2. 3 if x is equal to 1, and negative x plus 2 if x is greater than 1. So the first thing that I'll do is I'll graph this by ignoring the if conditions, and I'll come back to those at the end. So I've got y equal x plus 3. 3 is the y-intercept. X is the slope, 1 times x, means I need to go up 1 and to the right 1. Okay, y equals 3 means that I'd have a line right here at 3. And then y equals negative x plus 2 means that 0, 2 is on the graph, and I have a slope of -1. Okay? So now there's conditions on x. Okay? I only want the part of the first piece for when x is between -2 and 1, including -2. So anywhere that's less than -2, I need to get rid of. And anywhere that's bigger than 1, I need to get rid of. X is strictly less than 1, so I don't want to include 1 in my answer. And piece 1 would be done. Okay, piece 2, I got y equals 3 if x is 1. Well, that's going to just be a point. Since anything greater than 3, anything less than 3 would be erased. Piece 3, y equals negative x plus 2 if x is greater than 1 means that I would have 2 on the graph, but I want to erase everywhere that is less than or equal to 2, or less than or equal to 1. Okay? So anything that is greater than 1 needs to be kept. Anything that is greater than 1 means that 1, 1 is not on the graph. Okay? Now notice how that what I have here passes the vertical line test. The domain of f is the set of all x such that x is greater than or equal to -2. Here I am at -2 to 1, including -2. I'm including 1 on piece 2, and anything bigger than 1. Well, that's anything greater than or equal to 2 when you combine that. Okay, so that'd be the domain of f. Now the range of f is anything less than or equal to 4, or anything less than 4. 1, 4 is not on the graph. Okay, so anything less than 4 is going to be included on the graph there. The intercepts, there are 2 of them. They're at 2, 0, and 0, -3, where the graph crosses the x or y axes. F of 4, 4 is bigger than 1, so -4 plus 2 is -2. Okay, and just to check that I'm actually on that, yeah, here's 4, -2. When x is -1, -1 is between -2 and 1, so I need to be using piece 1. -1 plus 3 is 2. Okay, so is it continuous? No. In other words, to completely graph the entire curve, you need to lift the pencil twice from the paper in order to draw the curve. Okay. F of x equals the absolute value of x. So that is defined to be x if x is greater than 0 and -x if x is less than 0. To draw this piecewise function, I would begin by drawing each line. Okay, and now if x is, say, -6, then I've got negative the absolute value of, I've got the absolute value of negative 6. Okay, and I want negative x if x is less than 0. X is less than 0 there, with x being negative 6, so I want negative 6. Well, that's going to be 6. So at negative 6, I need to be up here. And piece 2 is saying, okay, do that in general now if x is a negative. Take the opposite of that number. That way you get a positive when you do the calculation there. So we end up getting 2 pieces. And piece 1 is defined at 0. So here's 0, 0. Piece 2 is not defined at 0. However, it connects at 0. And so this function is continuous at 0. It's continuous everywhere, in fact. Okay. The next function, f of x equals x squared, if x is greater than negative 2 or less than negative 1, including negative 2. You get 1 over x if x is greater than or equal to 1. Okay, so x being greater than negative 2 and less than negative 1, including negative 2, means that I've got this piece right here. I'm cutting that off at 1 because at 1 I'm graphing y equals 1 over x. And know the graph of y equals 1 over x. It's just I only want that piece if x is greater than or equal to 1. Now this would be continuous everywhere because there is no jump in the graph. There's no place where in the graph there's 2 pieces. However, they connect at 1. And so I don't actually have to lift my pencil at 1 in order to go from piece 1 to piece 2. The domain of f is the set of all x such that x is greater than or equal to negative 2. Okay, and I can see that. The range of f is the set of all y such that y is greater than or equal to 0 or less than or equal to 4. So let's see, if I'm between 0 and 4, yeah, I can see that. The intercepts, there's only one of them, right at 0, 0. And f of 3 is equal to 1/3. Is 3, 1/3. Continuous? Yeah, it's continuous. So nowhere on the graph should I lift my pencil in order to completely draw the entire graph. Okay. Final example is a graph involving a piecewise function. The cost for first-class mail weighing up to 5 ounces is given by $P, where P of x is given by this piecewise definition. If I graph the curve, anywhere that's between 0 and 1 gives me 0.9. Now notice how I'm graphing P of x and I'm not starting at 0. Okay, I'm starting at 0.9. So I have a break in the axis showing that I'm not starting at 0. You can have that or not. I guess I'm not picky about that. Anyway, at 1.1, we want anywhere that's between x and x is equal to 1 and x is equal to negative 2, not including 1 though. Okay, so if x is if y is 1.3, x is between 2 and 3, and if x is 1.5, x is between 3 and 4, and if y is between 1.7, x is between 4 and 5. Okay, including 5. I'm including the right endpoint on each one of these. In fact, it's not possible to weigh something or to mail something that weighs less than or equal to 0 ounces. Okay, so x equals 0 is going to have a open circle there, and the domain of P is the set of all x such that x is greater than 0 and less than or equal to 5. Okay, the range of P would be the set of all y such that y is equal to 0.9, 1.1, 1.3, 1.5, 1.7. And that's what I see on the step function. P of 1.5 is 1.1. 1.5. Okay, so that's piece 2, 1.1. P of 3 is piece 3. I'm including 3 there, and so I get 1.3. Okay. The interpretation here would be to say that P of 1.5 equals 1.10 means that it costs $1.10 to mail a package weighing 1.5 ounces. P of 3 equal 1.30 means that it costs $1.30 to mail a package that weighs 3 ounces. Are we continuous? No. You're going to have to lift your pencil 4 times to get from each step there. Okay. So the homework is on page 102. Be sure to look at these problems for me when you get a chance.